medium to another medium, then it bends. Question is why it bends. Light bends because it has a different speed in different mediums. Okay, now the question is why the light is having different speed in different mediums? Because optical density is not for all the same for all the mediums. Now what is optical density? Optical density is based upon how a particular material is made, how much permission it is giving for the light to pass through it. So if an material is optically denser, then it will not allow the light to pass easily through it. Light will become slower there. And if a medium is optically rarer medium, it will allow the light to pass freely through it. So speed of light will be more in rarer medium compared to speed of light in denser medium. I hope you are understanding. I even told you in the previous class, people generally think that glass dense, water dense, air rare. Like that you have a thinking. I told you it is wrong thinking, because any medium is dense or rare completely depends upon with what you are comparing it. For example, if you are comparing water with air, water is denser. Same water when compared with glass becomes rarer, because the optical density of glass is more compared to optical density of water. So glass is denser compared to water. Water is rarer compared to glass. But same water is optically denser compared to air or vacuum. So now if you compare air and water, then water is denser, air is rarer. Glass, which is denser compared to water, is rarer compared to diamond. So when I compare diamond and glass, glass becomes rarer, diamond becomes denser. So as I said in the previous class, I am repeating this point. Any medium, whether it is a dense medium or a rarer medium, it totally depends upon with what medium you are comparing it. So with that, I gave you the basics of refraction, the laws of refraction. There are two laws. First law says that incident ray, refracted ray and the normal lies in the same plane, and the second law says that sine of angle of incidence to sine of angle of refraction is always a constant. That constant is also called as refractive index only. Then I started speaking about refractive index in the previous class. I told you what is refractive index. So refractive index, I said you, is the ratio of speed of light in vacuum to speed of light in any medium. For example, if I write refractive index of a material, it will be C by V. It means speed of light in vacuum by speed of light in that medium. This formula gives you the formula of refractive index, where if I say refractive index of a medium is 1.5, it means what? It means that light travels 1.5 times slower in that medium compared to speed of light in air. Because when you put 1.5 out, you look at it, you check 1.5 is equal to C by V. What is the meaning of C? C is speed of light in vacuum. I hope you know that. C means speed of light in vacuum. What is the value of it? It is constant. 3 into 10 to the power 8 meter per second. Light travels with a tremendously large speed of 3 lakh kilometer per second. In 1 second, light can go 3 lakh kilometers. Several rounds of earth it can take in 1 second. That much fast is light. 3? Okay, thanks for the information. So this is the fastest the light can travel in vacuum, and if I use this equation, I will get the value of V as what? C, which is 3 into 10 to the power 8 divided by 1.5, which will make it 2 times. So it will become 2 into 10 to the power 8 meter per second, which gave us an idea that speed of light in this medium is 1.5 times lesser compared to speed of light in vacuum. So if a question comes in the examination, in the board it has come in the past also, if refractive index of a medium is 2.42, what is the meaning of it? Meaning is light travels 2.42 times slower in that medium compared to its speed in vacuum, isn't it? So up to here we have seen in the previous class. Today we are going to proceed from here, shall we? Shall we? Up to whatever I spoke now, we have discussed in the previous class itself. Today I am going to start talking about refractive index are of two different types. I'll talk about both. So first, let me make you understand and once again tell you that suppose I am having two mediums. For example, I am having medium 1 here and medium 2 here. Okay? Light comes from this medium. I said you this is the incident ray. The first step is to draw the normal. And the angle made by the incident ray with normal is called as angle of incidence. After that, light will bend. It has two options. It may bend towards the normal or it may bend away from the normal. That totally depends upon whether it is travelling from denser to rarer medium or rarer to denser medium. If the light is travelling from denser medium to a rarer medium, it bends how? Away from the normal. Very good. You should remember these things. And if the light travels from rarer medium to a denser medium, how it bends? Towards the normal. Good. So this rule you should never forget. If the light is travelling from optically denser to optically rarer medium, it always bends away from the normal. Away from normal means what? It means that light which was supposed to come like this will not come like this, rather it will take a bend away. Away means like this. It will go away from normal. And what is the meaning of towards? Towards means light which was supposed to come like this will bend towards normal, it will come like this. I hope you are getting my point. This means towards, this means away. So now whether the light will go towards the normal or whether light will go away from normal, it is completely depending upon what is medium 1, what is medium 2. For example, if I am assuming this to be air, assuming this to be water, now tell me, it will go towards because air is comparatively rarer than water. So rarer to denser towards normal, it will bend like this. This will become the refracted ray and this will become the angle of refraction, and very clearly visible angle of refraction is lesser than angle of incidence. Any doubt in this? Any doubt in this? I hope there is no doubt in this, right? Okay. And as per the understanding of refractive index, we know that refractive index of which medium? Of water with respect to what? Air is equal to what? C by velocity of light in what? Water. Do you understand this? If anybody has any doubt, ask me now. This equation is clear to you? Not clear, right? Okay. I said that refractive index is equal to C by V. I told Priyaranjan. Before some time also I recalled this. Refractive index of any medium is speed of light in air. You know why speed of light in air? Because the first medium is air and then second medium is water, so speed of light in water. So can I say that, if you see, you will realize refractive index of a medium, first medium, or in this case second medium, refractive index of second medium with respect to first medium is equal to velocity of light in first medium to velocity of light in second medium. Think properly, you will understand what I have written there now. As per the concept of refractive index, it is the ratio of speed of light in air. Why it was in air? Because the light was coming from air. If it is coming from some other medium, it will not become C by V, it will become V1 by V2. Luckily, when I am teaching this to you, V1 is what? In this case, it is air and V2 is what? In water. That is why it became C by VW. But general formula if I make of refractive index N21, it will become equal to V1 by V2. I will make it more clear, but up to here things are clear to you. Refractive index of second medium with respect to first medium is always equal to velocity of light in first medium to velocity of light in second medium. Now always remember what is the meaning of first medium and second medium. First medium is from where the light is coming and second medium is to where the light is going. First medium is from where the light is coming and second medium to where the light is going. Is it clear to you? Little bit? Okay, let us see how much time it takes to become clear. So, if I give you a condition, for example, if I am writing refractive index, suppose I am taking water, air-water combination, air and water, and I am trying to draw the diagram. This is the diagram, it will bend towards the normal. And what is the refractive index here? Refractive index of water with respect to air will become equal to what? It will become velocity of light in air by velocity of light in water. I wrote this already. Now assume the light is going from same air, but now it is going to glass. Okay. Once again, glass is optically denser compared to air, so it will bend towards the normal only. So, if I write refractive index of glass with respect to air, that will become speed of light in air by speed of light in glass. Do you agree with me? Any problem in this? If there is any problem, ask me what I have written here. Is it clear to you what I have written? G means glass, Tambi.
Understand what exactly is refractive index?
So, refractive index is the ratio of speed of light in one medium to speed of light in another medium. It is the measure of how much the light will bend when it is passing from one medium to another medium. Maybe if you see the previous class lectures, you will be able to understand it more better. Don't take too much stress. With time, you may understand. We are in the middle of the chapter, Preetham. Let us see. I'll give a separate session for you for making you clear. Now you just try to absorb whatever you can absorb maximum. Okay, Preetham? End of today's class, I will check with you whether you understood or not. Okay? Okay, fine. So, these two things are clear. Refractive index of water with respect to air is C by VW. Refractive index of glass with respect to air is C by Vg. One more thing I will say you now here. Refractive index of any material with respect to air can sometimes be just written as refractive index itself, that is refractive index of water. Sometimes they are not writing air itself. This can be written as refractive index of glass. So, suppose I am writing refractive index of glass is 1.5, it means what you know? Refractive index of glass with respect to air. If I am writing refractive index of diamond is 2.42, it means what? Refractive index of diamond with respect to air. If I am writing refractive index of water is 1.33, what does it mean? Refractive index of water with respect to air is 1.33. This kind of refractive index where they are just mentioning single medium is called as absolute refractive index. What refractive index? Absolute refractive index. Absolute refractive index means one medium is air. The first medium is air and second medium can be any medium. Are you getting my point? Because I told you refractive index of any medium is always a relative term. It cannot be absolute term. So, what is the meaning of absolute refractive index? It means that we are comparing with respect to air. Are you getting my point? But we can have a comparison of two mediums which are not having air included. For example, if I am having light entering from water to glass. Now, do you think that it will have the same value as 1.33 or 1.5? Definitely not. Kavin, Nitish, I think you are pressing somewhere here and there and it is disturbing. Okay, coming back. So, I was saying, please pay attention, I was saying that refractive index of a particular medium, if it is given as a value, then that medium is compared with air. But why the comparison will always be with air? It can be between two other mediums also. It can be water and glass also. It can be water and diamond also. It can be glass and diamond also. That time, the refractive index becomes relative refractive index. So, in simple words, if I say that refractive index can be of two types. One thing is absolute refractive index, which is speed of light in air by speed of light in a medium. Second thing, relative refractive index, which is speed of light in one medium divided by speed of light in second medium. To be very exact, absolute refractive index is also a type of relative refractive index only, but the first medium is air. Are you getting my point? So, in some books they will not write it as a two different types also. Actually it is not, because even absolute refractive index, even though we are not mentioning, like in your book they will write refractive index of glass is 1.5. What does it mean? Refractive index of glass with respect to air is 1.5. But if I write what is refractive index of glass with respect to water, will it be 1.5 now? No, it will change. How much will it become? How it will be same here? You be in class, your attention is somewhere else. Today's topic is little complicated. So if you are fully attentive only, you will understand. Otherwise, it will bounce. This is the only topic in this chapter which can trouble you. So today be very attentive. Let us see how it goes further. So I said that absolute refractive index is the scenario when the first medium is always air. In relative, on the other hand, there can be any two mediums. That is, if suppose I am writing Ng, I can write Ng is equal to C by Vg. Can I write like this? Suppose I am writing N of W is equal to 1.33. So I can write N of W is what? C by V of W, isn't it? Refractive index of glass is C by Vg. Refractive index of water is C by Vw. If I want to write refractive index of glass with respect to refractive index of water, what will happen? Check. C by Vg into Vw by C. Cc gets cancelled? Gets cancelled. What do you get? You get Vw by Vg. So understand that this becomes Ngw. Refractive index of glass with respect to refractive index of water is only called as refractive index of glass with respect to water, and that will become equal to Vw by Vg. So its value will be how much? Let us check. If you want to find the value, how much you got the value of, what is the value of Ng? 1.5. What is the value of Nw? 1.33. I can write in a better word to solve it simply. 1.5 can be done as 3 by 2, isn't it? And 1.33 is how much? 3 by 4, sorry, 4 by 3, isn't it? So 4 by 3. So how much it became? 9 by 8. So refractive index of glass with respect to water will be 9.9 by 8. Are you understanding this? Little complicated, I do understand, but not something which cannot be understood. It can still be understood if you are having concentration here. So what I am trying to tell, if all these I told by example, if I tell in numbers, then you will realize refractive index of a medium N1 is C by V1. Refractive index of second medium is C by V2. These refractive indexes are called as absolute refractive index. Why? Because I am comparing with respect to air. And if I want to find what is the refractive index of 1 with respect to 2, then it will become N1 by N2, and then it will become V2 by V1. This is the formula for, this is called as relative refractive index. Relative refractive index. It means we are comparing two mediums. So I hope something is clear to you now. Refractive index of a particular medium is C by velocity in that medium. Refractive index of two medium is velocity of light in the medium 2 by velocity of light in medium 1. Is it clear to you?
Sir, can you repeat, sir?
I'll repeat, Ryan. So first you copy this. I'll repeat it, first you copy. Those who are writing, please copy it first. You copy this first. This board is important, you copy this.
Sir, C is V of A.
C is?
V of A, speed of light and air.
Exactly. Whenever I am mentioning C, it is V of A only. So these things need not to write. With that example, you can write. I hope you got it. Understood, no? Have you copied it? Have you copied it?
Yes, sir.
Okay. Everybody here? Can I go to the next slide? Shall I? Kanishka done? Yeah. So now, once again I am repeating, Rayan, now pay attention. Refractive index of any medium 1 is speed of light in air by speed of light in that medium. Right, Rayan? Please unmute yourself. Refractive index of medium 2 is equal to speed of light in air by speed of light in that medium. Right, Rayan? This is your understanding? Be unmuted for some time. For 5 minutes, you be unmute itself. I am talking to you now, so why are you muting again? Yeah. Now,
Sir,
if
this is for absolute, sir.
absolutely absolute. Why it is absolute? Because here I am comparing with respect to air. Always remember that in absolute refractive index, it is with respect to air. Always remember this. So here I am comparing with respect to air only. Now, if I want to write refractive index of 1 with respect to 2, that is refractive index of 1 with respect to 2, I am writing like this, N12, which is refractive index of 1 by refractive index of 2. Now I am putting this equation, Rayan. It will become C by V1 and N2 is C by V2. CC gets cancelled. I get V2 by V1. This expression, that is refractive index of 1 with respect to 2, is always equal to refractive index of 1 with respect to 2, like this, is equal to V of 2 by V of 1. This refractive index is called as relative refractive index. Why relative word? Because you are comparing one medium with another medium, which is not air. And this is called as what refractive index, Rayan? Absolute refractive index. Are you getting? In the case of absolute refractive index, the medium from where the light is coming is always taken as air. That's all the difference is, nothing else. In this equation itself, if, now pay attention please, 2 minutes. If I would have written refractive index of, I know the formula is N12 is equal to V2 by V1, right? Right. If I am writing refractive index of glass with respect to air, then what will happen? Velocity of air by velocity of glass, which will become equal to C by Vg, which is only called as absolute refractive index, no? So, absolute refractive index is basically a relative refractive index only, with the second medium always taken as air. Are you getting my point? I hope something is clear to you. Shall I give some questions that will become more clear to you? Shall I? Priya Ranjan, understood something? Water means relative. Two different medium is relative. Yes, and the formula is this. I can write one more term here. You know what? Imagine in your 9th standard sound chapter you studied this, that velocity is equal to frequency into wavelength. You remember this? Yeah, that is only frequency, no? Yeah, displacement is lambda, 1 by time is frequency. So, became frequency by frequency into wavelength. Am I right? You know this formula? Everybody knows this formula? Okay. So, I can write V2 as nu into lambda 2 by nu into lambda 1. You may ask me why you have taken nu, why not nu 2? Because frequency is source dependent, frequency will not change. Frequency is source dependent, but velocity and wavelength, they are medium dependent. Velocity and wavelength, they are medium dependent. This question has come in the board examination. I will tell you how the question came. Question came like, when the light is traveling from one medium to another medium, what changes and what remains constant? Frequency remains constant, velocity and wavelength changes. See, frequency means color here. If red light is passing through air to water, do you think red light will become blue? No, right? Red will remain red only. Color will not change. Color will not change means what? If color will not change, it means frequency will not change. And frequency will not change, but the wavelength and the velocities will change. Guys, attention here. Okay, class is going on. This question has come in the board examination also. If I cancel frequency, then I get the equation, final expression I am writing, N12 is equal to N1 by N2 is equal to V2 by V1 is equal to lambda 2 by lambda 1. This is the expression for relative refractive index. Very important. It will not be there in NCERT book also, but it is very, very important, especially for competitive examination. In future, if you are writing any competitive examination, this is a very core formula over there. By this, you are understanding that refractive index and velocity are directly proportional, inversely proportional. N1 by N2 is equal to V2 by V1. It means what? N is inversely proportional to V, isn't it? That much you know. If A is proportional to B, it will become A1 by A2 is equal to B1 by B2. If A is inversely proportional to B, it will become A1 by A2 is equal to B2 by B1. So, here what is happening? N1 by N2 is equal to V2 by V1. It means N and V are inversely proportional. Same way here, N1 by N2 is equal to lambda 2 by lambda 1. So, N is also inversely proportional to lambda. It means more the wavelength, less the refractive, or vice versa. More the refractive index, less the wavelength. Less the refractive index, more the wavelength. And you know very well, more the refractive index, less the velocity. Less the refractive index, more the velocity. That's why I told Preetham, when you asked me what is refractive index is the measure of how fast or how slow the light will go in any medium. So, here if you see, you will realize that since velocity is that is inversely proportional to refractive index. Higher refractive index means lower velocity of light, and a lower refractive index means higher velocity of light. So if I ask you a question that light is entering from refractive index 1.2 to refractive index 1.6, its velocity will increase or decrease? It is entering from 1.2 to 1.6. Its velocity will increase or decrease?
Decrease.
Obviously decrease. And if I ask you whether it will bend towards normal or away from normal, what will be your answer?
Towards.
Towards, obviously, because it is moving from a rarer medium to a denser medium. If you are in the class, you are understanding this. Actually, I told you this topic is only the topic which can trouble you. But if you are clear in this chapter is very simple. Up to here things are clear? Sure? Shall I give a question now? Shall I give a question? Take one question, everybody, fast. Question is, all of you please, question is, what is the refractive index? What is the refractive index? I hope you are taking the question, Rayan Ahmed and Ananya. What is the refractive index of glass with respect to diamond? What is the refractive index of glass with respect to diamond? If refractive index of glass is given as 1.5 and refractive of diamond is given as 2.42. Make it fast. Simple question, make it fast.
Sir, 0.62.
0 point glass with respect to diamond, sure. It may be right also, I am just asking you. Any idea? You got 0.6, 0.62. Anybody else? Same or different answer?
Same, sir.
Same. So what did I ask you? Refractive index of glass with respect to diamond, isn't it? This is only I asked, you know. That means Ng by Nd. That's all, nothing to do after this. Ng is given as 1.5, this is given as 2.42. Just divide and you will get the answer. It is not a physics question, it is a mathematics question. Answer came, very good, Priya Ranjan. 0.62, 0.62 is the answer. I think everybody should get the same answer.
Sir.
Very basic division, very basic division. Take another question. Slowly I will increase the level. The question is, refractive index of glass is 1.5 refractive index of glass is 1.5 and that of water is 1.3. Refractive index of glass is 1.5 and that of water is 1.3. If speed of light in water, if speed of light in water is 2.25 into 10 to the power 8 meter per second, if speed of light in water is 2.25 into 10 to the power 8 meter per second, what is the speed of light in glass? What is the speed of light in glass? What is the speed of light in glass? Make it fast.
Sir, 1.95 to 10 to the
1.95 into 10 power 8. Anybody else? The same answer or different answer? Nitin Raghav has told 1.95 10 to the power 8 meter per second. Do you agree with what he has told or you want to change? Agree? Got the answer or simply agreeing? Got the answer. Pen? So how you agreeing, man? Simply. Just put your name and number here. All of you got the same answer? Yes, 1.95 10 power 8. So here what they have given in the question, again n of g they have given as 1.5, n of water they have given as 1.3, and what they have asked to find, velocity of what light in water they gave, glass they gave, water they gave, what they gave, water they gave, and what they asked, Vg. Just before some time I told you the formula, Vw by Vg will become equal to Ng by Nw, right? They are inversely proportional, I told in the previous page. I told or not? This formula you see. V2 by V1 is N1 by N2. So same thing will be applied here. If you apply that, then what is Vw? 2.25 10 to the power 8. This you want to find, Vg you want to find. And what is Ng? 1.5. What is Nw? 1.3. Solve this. Vg will become equal to 13 times of 2.25 into 10 to the power 8 divided by 1.15. Solve, you will get the answer as 1.95 into 10 to the power 8 meter per second. Correct answer, good. Done it. I hope you are understanding this. If anybody has trouble, please ask me. I am repeating and insisting you to be clear in this topic. Anybody has any problem in refractive index till now? What, Roshan? This question they gave three things. Refractive index of glass they gave, refractive index of water they gave, velocity of light in glass they were asking to find, velocity of light in water they gave. We know the formula. See, the formula was there in the previous slide. The formula is refractive index, that is refractive index of glass with respect to water will become equal to refractive index of glass with respect to water, and that will become equal to Vw by Vg. This formula I told you. Now Ng is given, Nw is given, Vw is given, Vg they want to find. Cannot you do this question now? If in an equation out of 4, 3 things are given to you, what is Ng? 1.5. What is Nw? 1.3. What is Vw? 2.25 into 10 to the power 8. And Vg. Cannot you solve this? That's all. Simple question. So I said you, if you remember this formula, many things you can solve. If just you remember the formula, that is N12 is equal to N1 by N2 is equal to V2 by V1 is equal to lambda 2 by lambda 1, which clearly shows that refractive index is inversely proportional to velocity and refractive index is inversely proportional to wavelength. That itself will help you to solve any question. Take another last question. Last question of refractive index category. Shall I give? A simple one only. Light of wavelength, fast, light of wavelength 6000 Armstrong, light of wavelength 6000 Armstrong. You know what is Armstrong? Have you ever heard this Armstrong? 1 Armstrong is how many meters? 10 to the power minus 10 meters. Those who don't know, please. Armstrong is a small unit. Armstrong means 10 to the power minus 10 meter. You have micro, nano. Micrometer means 10 to the power minus 6. Nano means 10 to the power minus 9. Armstrong means 10 to the power minus 10. Pico means 10 to the power minus 12. Femto means 10 to the power minus 15. We have so many units. Okay, coming back. So what I said, light of wavelength 6000 Armstrong in air, 6000 Armstrong in air enters a medium, 6000 Armstrong in air enters a medium of refractive index 1.5, enters a medium of refractive index 1.5. 1.5. What will be the frequency? What will be the frequency and wavelength? What will be the frequency and wavelength of the light in that medium? What will be the frequency and wavelength of light in that medium? Got the answer? Trish, I hope you are solving and not wasting your time in talking. What they have given in the question? Given data is what? What is that? Wavelength of what? Light in air. Lambda of air is given to you. Okay. What they're asking you to find? Lambda in water, isn't it? In water only they're asking, no? What is the question, guys?
Frequency and wavelength of light in that medium.
In that medium. Okay, that medium they're not told. Only okay. Refractive index 1.5, yes. So lambda in that medium they're asking, okay. And refractive index of air is what? 1. Refractive index of medium they have given. That is what? That means it is what medium?
No. They didn't mention medium.
They have not given the value of Ng.
No.
They have not mentioned the medium.
Oh, they have not mentioned the medium. Okay. So this is alone given. Anything else given? Nothing else given. Okay. They are asking you to find what is the wavelength and what is the frequency. Also, they are asking. No, both they are asking. They are asking you to find what. Okay. So frequency means nu. Frequency as well as wavelength. Both they are asking. So before some time I told the formula to you that velocity is equal to frequency into wavelength. Have I told you? So velocity of light in air only, obviously they are talking about air. So velocity of light in air is how much? 3 into 10 to the power 8 is equal to frequency you want to find. What is the wavelength value? In air, 6000 into 10 to the power minus 10. Am I right? Armstrong converted into meters. So what will be the value of frequency? 3 into 10 to the power 8 divided by 6000, or I can write 6 into 10 to the power how much? 3 here, 3 here and minus 10 there, minus 7. It goes above, it becomes 2 times. So it will become 0.5 times 10 to the power 15 hertz frequency. Is it clear what I have done? Just use the basic formula. Velocity is equal to frequency into wavelength. And velocity of the light in air is known to you. Easily you can get the answer. Is this step clear to you or any problem in this step? I have used the formula velocity is equal to frequency into wavelength. Velocity of light is how much in air? 3 into 10 power 8. Frequency is how much? We want to find that. And wavelength is how much? 6000 Armstrong. Preetham got the answer for this?
Sir, they asked for the other medium, no, sir.
Did they ask the frequency in another medium?
In the questions like frequency of wavelength of light in that medium, not.
Just before some time I told you, Preetham, frequency is source dependent, not medium dependent, right? So whether the light is in air or light is in that medium, frequency will remain the same. Understand? This frequency will not change, because I told before some time, frequency will not change if the medium is changing. What will change? Only the wavelength and the velocity. I told or not here? I wrote here also. See, frequency is source dependent. If a light is moving from glass to water, whether its frequency will change? No. What will change? Velocity will change, wavelength will change. Are you getting my point? So whatever frequency we have got here, that is the answer for even air or even any other medium. Now we want to find the value of lambda. How will you find lambda? How will you find lambda in that medium? That formula you have. You have the formula lambda A by lambda in the medium is equal to refractive index is given to you. Not given. How much it is given? N is given as 1.5 in the question itself. That is glass only, no? Yaar? So N of the medium is given as 1.5. So it will become N of the medium by N of air, isn't it? How I am writing this equation, you are understanding? Because I know that N is inversely proportional to lambda. So N1 by N2 is equal to lambda 2 by lambda 1. So if you are confusing, I will even write this first. N I will write first, then I will write lambda. So Nm by N air is equal to lambda air by lambda m, right? Now put the 5 values. Nm is how much? 1.5. N of air is how much? 1. Lambda air is how much? 6000. And this I am going to find. So if you solve, 10 to the power minus 10 also is there obviously. Then lambda of m will become equal to 6000 into 10 to the power minus 10 divided by 1.5. How much time it will go? 4000 time. So it will become 4000. So answer will become 4000 Armstrong as lambda of that medium. Understanding? This is the highest level of question possible in your examination. This is the highest level of question that is possible in any examination. It cannot go beyond this. Did you understand, Mridini?
Sir, can you repeat how you found the wavelength?
Yes, I will repeat. I said before some time, see this formula only we are using, only one formula. This formula only we are using in all the numericals. See this formula, Pritham. I said N12 is equal to N1 by N2 is equal to V2 by V1 is equal to lambda 2 by lambda 1. So N1 by N2 is equal to lambda 2 by lambda 1, right, Pritham? So here I am having Nm by Na, that will be lambda A by lambda m. Are you getting how it is coming? So now Nm is known to me, Na is known to me, lambda A is known to me. Cannot I find lambda m, Pritham?
Yes, sir.
Got it?
Yes, sir.
See guys, this is, again I am repeating, refractive index concept is not tough. It is not tough, but it is little new for you. That's why you are facing like complication in this. If you sit and think deeply, you will feel it is not a difficult topic itself. What I have used in throughout today's class is only one formula, which is refractive index of one medium with respect to second medium, which is refractive index of one medium by refractive index of second medium is equal to velocity of light in second medium by velocity of light in first medium is equal to lambda of light in second medium by lambda of light in first medium. Just by this formula, I have solved all the question. If you understand this, every question is simple. And again I am repeating, here if I take second medium as air, it becomes absolute refractive index, isn't it? Because if I take it as air, it will become speed of light in air by speed of light in the medium. That is only called as absolute refractive index, isn't it? So by this formula, you can solve any kind of numerical. If they give you refractive index of diamond, refractive index of water, wavelength of light in diamond, you can easily find wavelength of light in water. So any question can be solved by this formula if you are understanding this formula well. Otherwise, you cannot do anything. Okay? So I have the recording will be sent in the group. I know this topic has troubled you. Please go through the video once again and solve some questions based upon this topic today. If you want, I will send some worksheet from here. Yes. What? I'll send, man. If you solve only, it will be helpful. Okay. So solve the worksheet, then you will get an idea about this topic, and then next class we will start talking about the lenses. Okay.
The test this week.
Oh, this week you have a test of science. We have that. We will have questions up to refractive index.
Before that, sir.
Okay, reflection. Up to reflection. Okay. Sunday's test will have portions till reflection only. Okay. But please, guys, don't get afraid of refractive index. It will haunt you more. Today itself, solve some questions, become strong in this. Okay. Bye bye. Take care. Good night. I have taken attendance. Bye bye. Take care. Girls will go first, then boys will follow.